Nix. So this is an application used to keep the IDE friendly during video generation, open sourced by Byte. So this model and its application method make it an extremely powerful model. It is almost compatible with our Y2.1 ecosystem. For example, in this video, we can see how it operates within the VACE system. Then let's take a look at the workflow. I'm using the largest online configuration platform, RunningHub. First, see the basic process. The models are available on KJ's Hugging Face page, or you can check the model community or my profile for downloads. The business process completes a tattoo video task by cropping out the face from the image and maintaining ID consistency throughout the tattoo video. There's no problem in terms of similarity reference, especially since we can further enhance it using the VAE framework later on. So it's a model for a tattoo video, so probably many people would like to do tattoo videos. So here we naturally introduce the VAC model. The VAC part involves configuring on top of the basic workflow using the VAC Silver node, which is a typical node, and then feeding it into our new node to replace it. We set it to 81 frames, constrain the image width and height. For image to video generation, you can input the starting frame. Actually, you can also input the ending frame to get the width and height directly and then run it right away. I set the steps here to 4, but 6 steps are available. It doesn't make much difference. So using 4 steps is faster. The LoRA loader defaults to a 2.1 acceleration model and an HPS 2.1 model. Here, you can choose to integrate either the fast one or PUSA model as the game model, adjusted according to your needs. Here are several input options for images, including IP image, reference image, and image and video inputs for VAE. We can load the same image as shown in the process above or load them separately. Even if some are not loaded, the program can still run normally. The model in Nexus can load the full version as Kay mentioned, but in terms of performance, it feels that the more lightweight model is better. So we decided to use the lightweight model instead. There are still uncertainties because officials said that the full model should be capable of handling more advanced tasks. Navigate to RunHub, click AI or the link in the description to register, and you'll receive 12 HP. Logging in daily will also give you 100 points. The corresponding AI workflow for the video. All AI applications that can be started with one click have been synchronized and deployed online, allowing online operation and testing. The first and last frames involve inserting an image into the end frame of VAC, which is obviously very abstract. But if we input 2 characters here, we can see that consistency is actually maintained throughout the transformation process. Except for the first and last frames, it maintains consistency with our reference ID throughout. Here you can also adjust the IP and reference image, so it is a good choice. Very strong, not just in the way the process is structured, but also in terms of reference strength. The intermediate process is actually not much affected by the input fake frames. It mainly affects the face. The function here involves hand-drawn keyframes, pseudo-frames, reference IDs, and prompts. Because our prompt was playing basketball, these 2 streams use face swapping in image to video generation. Before making image to video, first do face swap. After face swapping, we can use Nix during image to video generation to maintain identity consistency. This is the input ID image. For the reference image, I'm using the image after the face swap in front. In terms of this task, it will be more integrated because when we look at the reference images, we take into account elements beyond just the face. The 5th process is using facial features as a reference for single image practice. The VAC process involves generating videos from images. If we input the entire image, there should be no problem. But if we only want to reference the faces from our image to video generation, we can isolate the face and then generate the video based on that. So what exactly are we trying to do here? Uses the VAQ model simultaneously. Enhance facial consistency with the Nix model. The initial baseline is problematic, it's a VAC issue, but later on we will combine the strengths of both methods to achieve an extreme level of similarity in facial features, which serves as an enhanced approach for the fundamental process of tattoo video tasks. The last step is to use pose videos for guidance. This kind of guidance still emphasizes an extreme similarity in facial features. What about the animate model with 2.2 parameters? It can still create similar characters. But as multiple renderings reduce similarity, this is an exploratory process where we lock the face using Nix and then proceed with VAB's post-guided video conversion using a reference image inputted here as a face. You can also enhance it further in this area. In summary, these are 6 processes combining Nix with VAE models, but they don't cover all possibilities, and I haven't applied anything related to audio yet. We'll look at it later, and I encourage everyone to take my process and adapt it further. So most of the time, this channel shares open source models and projects, but closed source models are where RunningHub really shines. It brought down the prices of many popular models, such as V2, Kelling, and Wanxiang. Some specifications were even lower than the official published prices. The more you use it, the more you'll realize that saving up bit by bit really saves money in the long run.